Quadratic inequalities. Inequalities are something you've encountered at GCSE, but sometimes not very confidently, and it gets more complicated at A level. So first of all, let's talk about inequalities. So we've got a number line, and we want to indicate, using notation, the section of the number line from -7 up to 1. So what we do is we say that we want the x's that are between -7 and 1. And we're allowed to be 1, so we could say or equal to, and we're allowed to be -7, so or equal to. So what we've got there in that notation is actually two things. We've got x bigger than -7, and as well, also x less than or equal to 1. And it has to be both those things, because, for example, -20 is less than -1. So if you just had this one, you might think that x is -20 is fine, because it's smaller than 1. But obviously it's not, because it has to be bigger than -7. So when we're squashed between two numbers, you can see that in the notation, that it's squashed between two numbers on the notation as well. Okay, second example, this isn't squashed between two numbers, this is everything to the left of -3, or it could be -3.
That's because of the filled in dot, isn't it?
Yes, exactly. In this last example, we've got everything to the left of 1, but we're not allowed to be 1. We've also got another bit, or everything to the right of 7, everything bigger than 7, but not allowed to be 7. Now, we can't combine those two, because you cannot be simultaneously smaller than 1 and bigger than 7. So this is not the same as the first example, where we had two inequalities that we bring together into one. That's when you've just got one little bit squashed between two numbers. This is two entirely separate sections of the number line. The thing's smaller than 1, the thing's bigger than 7. You can't be both at the same time. Okay, you've got an exercise in your packs, which hopefully will lead you to understand how to read from a graph what an inequality is saying. So we've got the same graph every time, x squared minus 4x minus 5. And the first three questions ask you, where is it equal to something? So where is the graph? This is the graph. Where is the graph equal to 0? Have a height of 0. This says the graph, and then this says height 0. So that's there and there. The solutions would be x is -1, x is 5. Okay? Where is the graph having a height of 3? I have no idea. There and there. Can I solve this? Should I try? Mm-hmm. Okay, I'll try. It's not as obvious what the answer is. So I'm saying, where is x squared minus 4x minus 5 equal to 3? So x squared minus 4x minus 8. Does that look like it factorises to you? No. It's both there and there. I'm making it up. Oh, no, look, I'm not very good at not doing things. It just makes me feel I have to do it. X minus 2 squared minus 12 is 0. So x would be 2 plus or minus the square root of 12, which is 2 root 3. I did that a bit quickly, but you should be able to do that, actually.
Previous video.
Yeah, you should be able to do that. I just did it a little bit quick because I didn't have it. Oh, the point is that the notation says the graph has height 3. The graph has height 0. This says the graph has height, well, you can't have a height of -9, but that sort of thing. That's here, only one of those points, x is 2. So, the next ones are where we get the inequalities. The graph has height less than 0. Has height, it's not really a height if it's negative, but anyway, has height which is negative. That's what that says. So, for example, there's an example. 2. The height's negative there. Oh, the height's negative there, and there, and there, and there, and there, and there. So basically, anywhere between these two.
Yeah.
Anywhere between -1 and 5. Anywhere between these.
But do you need you don't need the equals, do you? Because you can't have a height of 0.
I totally agree with you. I totally agree with you. We can't have the exact point 5 or the exact point -1. So I shouldn't have said or equal to. I should say between -1 and 5, but not being allowed to equal those, because at those points the height is 0, not less than 0.
Yeah.
Okay. The graph has height, oh look, negative or 0. That's what that says. So that point, that point, that point, that point, that point, that point, this point, this point.
Yeah.
Basically, anything between 1 and 5, -1 and 5, or in fact, -1 and 5. Okay, so this one, the graph has height what?
Well, it has a positive height,
Yeah.
anything from 0, but not including 0.
Yeah, has a height which is positive. So here's one example of a point where the height is positive.
Yeah.
Are there any others?
Here,
Yep,
and here,
yep,
and here,
Yeah.
and here,
yeah,
and here.
exactly.
Yep.
So if we point those down at the actual x values, that one, 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 that etc.,
Yeah.
you can see that we're going to end up with to the left of -1 and to the right of 5.
So we're going to have any x that's smaller than -1,
Yeah,
or x that's bigger than 5.
Exactly.
But not including them, so we haven't got including them.
exactly. And a nice thing that I think is nice about the notation here is that you can see on the green one that you had one section
Yeah.
and one inequality. One section, so one inequality.
Yeah.
Whereas on the red one, we've got two separate sections
Yeah.
and two separate inequalities.
Is it or and?
It's a very good question. I would use or because I think it's a bit dodgy to say and, because if you say and, then are you saying that you're looking for an x which is simultaneously bigger than 5 and smaller than -1, because that's impossible. So
But I guess the solutions are less than 1, -1, or bigger
yeah,
than 5.
but equally you could argue that the answer to the question
It's both those sections.
is both those sections. So it's that section and that section. So either is fine. You can say whichever one. To be honest, you can just write it like this.
Yeah.
You can just do it on the graph like that.
There's a philosophical debate about that.
Yeah, exactly. So final one, the graph, the x squared minus 4x minus 5, the graph has height
Positive.
positive. Yeah, positive or 0. So that's these bits, could be that, could be that.
So it's going to be x less than or equal to -1, or x greater than or equal to 5.
Exactly. Okay, so I've got something that looks quite tricky here. It's a simultaneous inequality. Simultaneous. We've got to do two of them. Now, the right-hand one, you really should have remembered from GCSE. 4x minus 7 is bigger than 3x minus 6. X is bigger than 13. Is that right?
I thought you couldn't see x as a general plus or minus.
You can subtract.
So
You can add and
multiply.
you can't multiply by x because it might be positive or negative, and if it's negative you have to flip the sign. But you can subtract. So I just took 3x off each side and then added 7 to each side. So x needs to be bigger than 13. So 11, 12, 13. It's all of these ones over there. Yeah, all of those ones. X bigger than 13, but it can't be 13.
Yeah. Tiny capita.
Yes. Or you can do a little empty circle to show that it can't be 13. Okay, well we've also got this inequality. Can you solve that one?
So we're looking for where the graph
Mm-hmm.
has a height bigger than 0.
Yeah. Or
0. So those are the points where it's 0.
Yeah.
And then all of this
Yeah.
is a height that's bigger than 0.
Yeah.
So it's going to be x is less than or equal to minus 1.
Yeah.
Or x is bigger than or equal to 5.
Yeah, exactly. So if I use a different colour, if I use green and label that on this number line, we could be minus 1 or smaller than minus 1 forever.
Yep.
Or we could be 5 or we could be bigger than 5 forever.
Yep.
Okay. So what the question asks is are there any numbers, is there anything on the number line where both these things are true? Yeah.
There, isn't it?
Over there.
Yep.
Literally, that's the only bit. X
Because
bigger
they're the
than
bits where the
13.
lines overlap, aren't they?
Yeah.
So our answer is x bigger than 13.
Yeah, because that's the only part of the number line where we've got green and red, where both the quadratic inequality and the linear inequality are both true. Exactly. Okay, let's try, no, let's not try this. We've already played with this one, haven't we? We've played with this one, yeah. I think you're ready to try some yourself. Okay, so you've got 6 to try. So pause the video, try them yourself, have a go, and then unpause the video when you've had a go, and we'll go through the solutions. Okay. So this one says the graph is negative. Now, I can tell straight away that that's going to be all this stuff, but I don't know what the roots are of the quadratic. Can I factorise? I think I can. 6, 4, 4, 6, no. 2, 12, 2, no.
It's going to be 7 and something because it's an odd.
No, because 7 plus 24, 21, 28.
8 and 3?
8 and 3. Okay, so the quadratic itself, the graph, has got roots at 3 and 8. So this is 3 and this is 8. And what I want is to be in between them. So I've got 3 and I've got 8, and I want to be in between like this.
Yeah.
But I can't be 3 or 8
No.
because I'm not allowed to be 0. I have to be actually negative. So it's in between those two. Okay, next one. I think I can factorise this myself. Thank you. So I want the graph to be positive. So that's all this stuff and all this stuff. I know that this is, well, that one gives me x is minus 3 and that one gives me x is minus 4 as roots. So that's minus 4 and that's minus 3. And I know I want to be to the left of minus 4, or indeed equal to minus 4, or to the right of minus 3, or equal to minus 3. 2 sections, 2 inequalities, 1 section, 1 inequality. Okay, oh, it's the factorising that's difficult. Okay. The graph is negative. Okay, so I want the bits where it's negative. So I want the graph is below. So I want these bits. So it's going to be the x's between. Doesn't it?
If that was 7 equal to. Change it to a 7. Change it to a 7. 8 to a 7.
Well, can I use the formula?
Just change it.
I think I should use the formula because I don't. Okay, I'll change 8 to 7. Change what? Change that.
Yeah.
Okay. Now what?
So it's you've got 1 and 3, but you need 4 to be multiplied by the 1.
4
x 1
1
3
3
minus 1.
No. Yes. 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 In fact. Okay. So this one gives me x is 1, and this one gives me x is 3/4. So this would be the 3/4, so this would be the 1, and I want to be squashed between the 3/4 and the 1. What about this one then? Do these really not factorise? I think maybe they do, and we're just being a bit silly.
No, really. If this one here factorises with a 7, it can't factorise with an 8, can it?
I don't know.
It can't.
Okay.
It can't. I promise you. It can't.
Okay.
This factorise? No, it wouldn't. Ignore me.
6 and 10 is 60. So we need two numbers that times to 60 and add to 11. Yeah. Times to 60 and add to 11. Oh, look. 4 and 15.
Add to 11. What?
Yeah.
How am I?
Yeah, no, this is going to work.
Okay.
I just don't know how. Okay, look, this is what you do. You go 6x squared, then you do add 15x minus 11x. No, minus 4x, because that's your 11, minus 10.
Yeah.
Then you pull out 3x, no, hang on, you pull out 3x, brackets, 2x, add 5.
Yeah.
Does that work?
Yeah.
And then if I pull out minus 2, 2x add 5, so it equals 2x add 5, 3x minus 2.
Yeah.
So the roots are minus 5 over 2 and 2/3.
Yeah.
So the quadratic looks like this with minus 5 over 2 here and 2/3 here. And I want the graph to be positive, so I want these bits and these bits. So I want to be squashed between, I want to be to the left, not equal to, minus 5 over 2, or to the right of 2/3. Yeah, the whole bit's the factorising. Okay, last two. Oh no, it's one of these. It is the last two, but it's one of these. Okay, so 3x less than 12,
Yes.
x less than, yes, I should actually have been able to do that, shouldn't I? 4. Okay, x less than 4. So on a number line, here is 4. I know I need to be to the left of 4, not including 4.
Yeah.
Okay, that's that one done. This one, 5 and 2. So the roots are 5 and 2, and I want to be negative. I want to be below. I want the y coordinates to be negative, which is a reason. No. Well, equals naught. Yeah, equals naught.
For now. Yeah.
To find the roots.
Yeah.
So I want to be between 2 and 5, but not actually be 2 or 5.
Okay. Oh dear.
So where have we done both?
In there.
Yeah. How would you describe that?
So we can't be 2.
Can't
So
we?
it's one.
Why can't we be 2? Oh yeah, we can't be 2.
But it's only one section.
Yeah.
So
I should have done
that really should.
this, shouldn't
Yeah.
I? Yeah. I can't be 2.
We can't be 2, and we can't be 4 from
No.
this one,
No.
but we are one section.
Yeah, I
Yeah.
agree with that. Brilliant. Last one.
Right.
Okay. 3x. 19.
No, minus.
Good point. Good point. 50 minus 15.
Yeah.
Well, that's better. That's minus 5, isn't it? Excellent. Okay, this one. I think that's yeah.
No, change that to a plus. There
Yes.
we
Okay. And so the roots are going to be 4 and minus 3. So if I was drawing this graph, it would be minus 3 and 4 would be the roots. It says here that I want the graph to be above. I want the y coordinate, the graph above. So that's this stuff and this stuff, not the stuff below. So I want to be to the left but not including minus 3, or to the right but not including 4. So if I put this one on, so I want to be this but not that,
Yep.
or not that but this. But then we have the other one as well.
Which is x greater than or equal to minus 5. So this is minus 5. We
Yeah.
want to include that,
Yeah.
and we want all of that.
Okay, and now we need to do where is red and green.
Right, well that's red and green,
Yeah,
and that is also red and green.
yeah,
So that is including minus 5,
yeah.
but not including 3.
Because
that's
of 3
open
wasn't
one.
red, yeah.
Minus 3.
Yeah,
Or I don't know,
Yeah.
it's a whole slew, I don't know. X greater than 4, but not including 4.
yes, because the red one said it couldn't be 4.
Yeah, so that whole solution set.
Excellent.